All right, welcome, ladies and gentlemen, to another live stream. This is week 6, and I am already full with some questions. So I appreciate you guys submitting some questions to me earlier. A lot of people were definitely in on the chat ahead of time, and so I do appreciate that. It just gives me a little bit of time to kind of take a look at the questions and everything that I have going on here. And I forgot to actually check in my mic level, so I hope everything is coming up good. Okay, well, it kind of took me a little bit longer than expected to writing down the questions, so that's why I kind of came up here a little bit. Just wanted to make sure everything is coming along just all right. So, but I see a lot of you guys, Nobody Important, Sky, Roddy's, and Ariats. Good to have you guys into the live stream. So what I'm going to do is I'm going to cover these kind of 6 questions. And let's see, these, there we go. Well, maybe not. There we go. All right. So I'm going to cover 6 questions just to kind of go through them, answer any questions I have for you guys. I might be able to do some additional questions for you guys that if you still have some questions in the chat or you just kind of get in a little bit later, then I'll be, try to see if I have some time, but, trying to keep this down to another, just about a little 30 minutes here on the stream. So we have a graph and a piecewise functions, writing the equation of an ellipse. Then we'll go ahead and do writing the equation of a parabola, which I forgot to write in there, so I guess I could do that, write the equation of a parabola. All right, then we're going to write the equation of a line through a point that is perpendicular to another line. We're going to determine the end behavior. Somebody gave me a question, and I forgot to actually write it down. Let's see if I can find that. So that is the end behavior of that equation. Y is equal to x to the 5th minus 7x cubed plus 2x minus 3. All right, and then we're going to solve and graph a quadratic inequality. And then we are going to I'm just going to do the rational zero, list the possible zeros. List the possible rational zeros. And then in addition to listing the possible rational zeros, I'll kind of tell you how to take your next steps to go ahead and find the remaining zeros from there. So those are the kind of questions that I have on the board. We'll kind of see how long they take for me to work through them. And then after that, if I can answer kind of your questions, guys, I'll be more than happy to see what I can do for you. All right. Got some, hey, Rob. Hey, Victor. Hey, Big Red King. Well, I'm very happy, Will, to help you out. And practically logarithm the inequality, unfortunately, and Matt took this last year. Very good. So just a reminder, guys, when you are sending me, in the questions, the more specific, actually, if you can give me these problems, these are all problems that are student provided. So I'm not making up the problems. I'm not trying to cover certain concepts. Obviously on my channel, I do certain videos that are mostly from the algebra and pre-calculus, kind of framework, at least because that's what I'm teaching, and that's what my other live streams are. But these open Q&As are just kind of based on what you guys send to me. So I'll try to, obviously every week at the beginning of the week, usually on Sunday or on Monday, I'll be making a post on the community tab for you guys to submit some questions, and you can either do it, send it to me there, or if there's something a little bit more advanced that you need to take a picture, you can always send it to me on Facebook on my free math videos, and that allows you to kind of like take a picture, and something like that for there. So otherwise, let's go ahead and get into the math, so we can get some additional questions maybe you guys have. So all right, so graphing this one, and this is a good question. So there's a couple different ways we can do this. Actually, in this one, I'm going to do this a little bit differently than the way that I taught in my class, because in my class, we kind of did a little bit more basic ones than this, just because I like to teach my students a little bit more in progression. And I know a lot of students, they just struggle with piecewise functions so much. So I've kind of took it a little bit, I've been taking it slower a little bit the last couple of years. However, my students would know how to do this. The x squared minus 1, that's going to be a y-intercept, and it's going to go up. Now, again, notice that we have these constraints at -2 and 2. So I'm actually going to graph this fairly decently. So therefore, we can see where exactly all these points are, or where exactly kind of the graph is a little bit more in depth here. So I'm going to plug in, so remember we go up 1 over 1, and then we can go up 2, and that'd be up 4, right? So 1, 2, 3, 4. Okay, so I'm just going to, oops, don't want to do the V-shaped graph. Oh, let's do this in red. There you go. And then we can differentiate between no. Sorry. Let's try to fit the width. Then we can go ahead and make sure that we can differentiate between the questions, or the questions and the answers. All right, so there's the horrible parabola. We have 2x plus 3, which is going to be at 1, 2, 3. There's the y-intercept, and then that's going to be up 2, and then over 1. Or it's going to be down 2 and over 1. So that's going to look something like that. Okay, so I'm just going to graph these all as they are. And then we have x squared plus x minus 6. Now this one doesn't really come as obvious for a lot of students. But remember, if we were to factor this, or if we wanted to find the y-intercepts, like for instance, if we were going to say, well, graph y equals, x squared plus x minus 6, and I said find the x-intercepts, you'd set that equal to 0. You would factor this to give you x plus 3 times x minus 2. And therefore, you'd figure out that x equals negative 3 and x equals positive 2. So we can go to negative 3, 1, 2, 3, and then positive 2. And obviously, we know that a is positive. So I don't really know how far low this goes. You could figure out the x and y intercept if you, or the vertex to be able to figure out where it is. But for right now, we're just going to kind of look at these and say, all right, that's what the general idea is, what these graphs look like. Now let's kind of figure out, basically this piecewise function is a combination of all of these onto one graph. All right, so we have x squared minus 1. That's for x values less than negative 2. Well, if you see at negative 2, we're already up to 4, right? So 1, 2. Okay, and that's going to be an open circle, and that's just going to go like that. Right? You can see all I'm doing is graphing from negative 2 up. The rest of the graph is not going to be a part of it. Then I have negative 2x plus 3. So if I was going to go down to negative 2, let's see, it starts at 3, down to over 1, and then down to over 1. So that's equal to negative 2, and then up to over 1. So if I follow that line, now that's an open circle. Sorry, should do that as an open circle. So now, instead of graphing this line for all real numbers, I'm only going to graph it from negative 2 to 1. Now, in this case, how do I know exactly what 1 is? Where exactly is 1? I know the graph has this kind of shape, but what exactly is 1 here? Well, what you could do is you could always plug in 1 in for x. So that'd give you, 1 squared plus 1 minus 6. So 1 plus 2, and that equals negative 4. So I know the shape here. So 1, 2, 3, 4. And that's going to be greater than or equal to. So probably since it has to cross at 2, and we're at negative, let's say we're at negative 1, or at positive 1, right? And it crosses at 2. Yeah, so I'm pretty sure this comes up just like that. So it kind of looks like another version of a quadratic here. So probably from there, goes like that, and then shoots up like that. So not the best. And obviously, a lot of this, though, you can see that there's 2 jump discontinuities. And hopefully you kind of get the general idea of at least, understand what each and every graph looks like. And then basically all you're doing is restricting the domains for each of those graphs and then combining them together. And that's basically how we graph piecewise function. So it doesn't matter what exactly your function is, but you're going to follow that exact same process. All right, the next one says write the equation of an ellipse given at the center. So whenever I'm doing, writing the equation, I always tell the students to just draw it. So 1, 2, 3, 4, 5, and then 1, 2, 3. Okay, so that's the center. Now remember, let's see here. If so we have the 2 equations of the center, which, remember those as well. If it's going to be tangent, so that means if this point is tangent, that means there has to be a point here and there has to be a point there. right? Because if you were to kind of like draw a makeshift ellipse here, right? If the x and the y-axis are tangent, that just means they're going to touch at that one exact point. Well, if the one exact point is, where they're going to intercept, they can't cross the x and y-axis, so they have to just touch at those two values. So then we recognize this to say, well, that is an axis, and that's an axis. That is the shorter axis, right? You can see that that is going to be your minor axis, and it looks like that would be your major axis. Now, again, that's only half of the axis, right? Because, actually, never mind. Yeah, that's half of the axis, so that is the letter, that's B, and this would be A. So in this case, we can say, well, how far did we go over? Well, we went A is going to equal to 5. B is going to equal 3. Now, again, you could say, well, you're going down. Well, yes, but I mean, you could, B, it doesn't have positive or negative because remember, the formula is squaring it, right? Since we have a horizontal major axis, A squared is going to be under the X term. And remember, X is always with H. Remember, this is your H comma K. That's what I was trying to think of. I was like, there's something has to be with the HK. So the formula looked like this. X minus 5 squared all over A squared, which would be 25 because it's horizontal. So horizontal, A is always larger than B, so it's going to be under the X, plus Y minus K, which is 3. No, sorry, that's going to be a positive 3 because it's Y minus a negative 3 squared divided by 16 is equal to 1. All right. Next one is write the equation of the parabola. The focus is 2, 3, and vertex 2, 1. So again, just sketch the information. So we have a point 1, 2, 1, 2, 3. So that is your focus. And we have the vertex of 2, 1. So remember, when you're looking into a parabola in conic sections, the vertex always opens up towards the focus. So my vertex is going to look something, like that. And remember, the distance from the vertex to the focus is P. So in this case, we can say P is equal to 2. All right, now since this is going to open up, we know that X is going to be squared. So our general formula is Y minus K squared equals 4P times, oops, sorry. That's the other equation. So we have, it's opening up, so this is X minus H squared equals 4P times Y minus K. Again, your vertex is your H and your K, just like in the last example. And actually, let me just write down this last one. Here's the formula where I got this. X minus H squared over A squared plus Y minus K squared over B squared is equal to 1. So you're going to want to know that for your conic sections. You're going to want to know this one for conic sections as well in terms of the parabola. And then I already have my H and K. And I already have my P. Now I found the P again by graphing the vertex and the focus. So now I just plug everything in. So I have X minus 2 squared equals 4 times 2. That's my P times Y minus 3. And therefore this gives me X minus 2 squared is equal to 8 times Y minus 3. And there you go. All right. Write the equation of the line through the point -2, 5 and perpendicular to x equals 5. Now, in this one, again, I think the student said you don't need to graph it, but let's just graph it. Let's graph the point -2, 5. So we have -2, 5. What the? -2, 5. Oh, okay. So 1, 2, 3, 4, 5. So here's the points, right? There's your points. And then it has to be perpendicular to 5. 1, 2, 3, 4, 5. Okay, so again, I got to take a point. From here, I got to draw a line perpendicular. Well, I can't draw like a slant up or a slant down. It needs to be directly horizontal. So if I was going to take a line, do directly horizontal there, right, to create my 90-degree angle, I can say, all right, that's a horizontal line. So if vertical line is x is equal to 5, then this is going to be y equals. Well, how high am I up on the y-axis? 1, 2, 3, 4, 5. I'm the same as the y-coordinate. So the answer is y is equal to 5. Determine the end behavior. So we just kind of cover this again in my class. So I'll just kind of do a quick little version or a quick little thing to remember. First thing is we always only care about the leading term. So that means we're caring about the highest exponent, which is what we call the degree. Let's leave that. Let's do this a little bit bigger. So all we care about is the highest exponent, which is the degree, and well as the coefficient of that leading term, which we call the leading coefficient. Now, the degree can either be even or it can be odd. The leading coefficient is going to be positive or negative. Any other variation in the even and odd or positive and negative for leading coefficient is not going to change the end behavior. Now, the way that I remember this is I know even and positive leading coefficient goes up and up. I know it's something that's even and negative goes down and down because basically I remember that from the quadratic. As far as odd, you can remember a line. Falls left, rises right. Here, this is going to rise left, falls right. And I'm going to do a much longer video kind of explaining or working through this coming up. So I don't want to take too much time, but the nice thing for you to know is it doesn't matter if the degree is, this is x to the first. This is x squared, right? It doesn't matter if it's x to the first, x to the 11th, x to the 199th. The end behavior is going to be the same as x to the first. So if either it's odd, then it's either going to be positive or negative. It's either even and the leading coefficient is positive or negative. Well, here we can see the degree is odd and the leading coefficient is positive. I don't know how you want me to write the end behavior, so I'm just going to do a basic one. Just say falls left, rises right. We do obviously in pre-calc because we get a little bit more into the formal math stuff. Oops, I'll say right rises. Rises right. Falls left and rises right. All right, getting there. Only 2 more questions, at least left on the dockets. So I do appreciate for those of you guys that are joining, have at least joined in since I got through, started on the live streams. Let me actually check here. Uh-oh. Did I forget to check? No, okay. I just want to check my live stream health. Want to make sure everything's going good. But I just want to let you guys know, so far we're doing pretty good on time. So I did get all my questions submitted. I always like to do 5. I got 7. I said I'll do it. And we'll kind of see how long these kind of take me. But if you guys do have some questions, feel free to post them in there. I can't get to everything, but I'll try to do my best to maybe see if I can add 1 or 2 questions here for you guys. So, all right, let's get into the next one is solving graph. Now, when we're solving graph inequality, really the easiest thing to do is look at this as just an equation. X squared minus 7x minus 8. Now, if I was going to solve this is actually very similar to what we did for the piecewise functions. We could complete the square and get this in vertex formula, but that doesn't sound like fun. I think the easiest thing to understand here is where are the x-intercepts. If we understand the x-intercepts and we understand the end behavior, which again, we have even and positive, that means rise left, rise right, right? So let's find the x-intercepts. To find the x-intercepts, we're going to set y is equal to 0, and we're going to solve for x. Well, to solve for x, we're going to need to factor. So I'm going to get x minus 8 and an x plus 1. All right. So therefore, my x-intercepts are x equals 8 and x equals negative 1. So let's go and graph this. So we have positive 8. So 1, 2, 3, 4, 5, 6, 7, 8, and negative 1. Okay, so those are my 2 x-intercepts. I know, based on what I just taught, the end behavior is rises to the left and rises to the right, right? Or obviously you should just know that's a quadratic, and it's going to look like that. So the graph is going to look something like this. I don't really have enough information at this point to be able to give you any better of an accurate graph. However, we don't need that. To solve the inequality, it says what x values are going to produce a value that's going to be larger than 0. Well, look at the graph. You can see that this graph, the y value, right? The y values are larger than 0 when x is less than negative 1 and greater than 8. So my solution is when x is less than negative 1, not less than or equal to, because equal to it's 0. We don't want it equal to 0. So it's going to be less than negative 1, or when x is greater than 8. Then I can just graph that on a number line. So I could say, well, here's negative 1. Here's 0. Well, let's do, I don't know, here's 5. Here's 8. So x has to be greater than 8, but less than 1. Okay, so my graph doesn't look that great, but hopefully you can see that's what you do for there. All right, last one, at least I have listed up here. So f of x equals x to the fourth plus 5x cubed minus 27x squared plus 31x minus 10. It says list all the rational zeros. The student did tell me that they wanted to know how to find all the zeros, and by using the guess and check method. And I haven't taught that in 5 years. Not that I can't do it. It's just I stopped teaching it because it took too much time. It was, in my opinion, as a teacher and for a student, it just wasn't a good use of our time in class, nor for students to really work through it, because we use graphing technology. So, I give this problem, or when we work on a problem like this, my students would have graphing technology. So, and plus, I want them to be able to find all the zeros. I'm not really concerned about them guessing and checking to figure out what they are. But I think if we do talk about the remainder theorem, we do talk about how to determine if something is a real zero. So let me kind of explain what we do. First of all, if I just want to find the list of real zeros, we're going to do the P over Q, which is called the rational zero test. Okay. So the list of rational zeros is plus or minus the factors of P over Q. So basically all you're going to do is you're going to take the factors of P, not negative, but just do plus or minus. So it's going to be plus or minus 10, plus or minus 5, plus or minus 2, and plus or minus 1. And you're going to take those all over the factors of Q, which thankfully for us is just plus or minus 1. So therefore, obviously, dividing by 1 is not going to change the factors. So therefore, our list of possible rational zeros, I'm going to put the plus or minus on the outside, is going to be 10, 5, 2, and 1. Now, how do we know if these are the list of possible rational zeros? How do we know if these are a rational zero or not? Well, what we can do is use the remainder theorem. If we plug in f of 1 and we get 0, then, let me do this. If f of 1 is equal to 0, then x equals 1 is a 0 of f of x. I don't know why you're giving me that time. Start that again. Of f of x. Batteries all right? Yeah. So basically what we would do in this case is you would list all the possible rational zeros. You plug in f of 1. So then you plug in 1 in for all of these x's. And if you get 0, well then guess what? You have a rational zero. Let's see if I can, and then you just move on. And then you say, all right, let's say 1 was not. Then you do negative 1, right? And then you do 2. And then you do negative 2. And you can just see how crazy this can get. Now, again, once you find a 0, then you're going to want to use synthetic division or long division. Let me see, actually, let me see if I can figure maybe 1 or negative 1. Let's see if I can do those in my head. So that would be 1 plus 5 minus 27 plus 31 minus 10. So that would be positive 21. Okay, so f of 1 does work. What about negative 1? That would be a 1 minus 5 minus 27. I don't think this is going to work. Minus 31. No, this is not going to work. All right, so negative 1 is not 1. So, but maybe 2 is, and I am not going to go through all this. But let's just do, let me show my work then for this, and I'll show you at least what the first step is. Because I would not, I just have my students graph these and be fine. But let's figure out, let's just confirm f of 1 real quick, and then I'll at least do the next step. F is 1 to the fourth plus 5 times 1 cubed minus 27 1 squared plus 31 times 1 minus 10. Right? So we get 1 plus 5 minus 27 plus 31 minus 10. And 6, that's 37. If I'm doing my math right, I'm getting 0. So therefore, now we know this is a 0. Now, what do you do with that? Well, again, you can use synthetic division, right? If you know you have a 0, then you can take that 0 on the outside, take all the coefficients of your polynomial. So that's going to be 1, 5, negative 27, 31. Make sure they're in order and make sure you're not missing any coefficients, and 10. If you're missing a coefficient, make sure you use a placeholder as 0. All right, and then you could do long division as well, but who wants to do long division for this problem? Because when you have a, just an integer, it's much easier to do synthetic division. So you bring another 1. And again, also, when we do synthetic division, what this is also going to do is also going to confirm that this is a 0. So 1 times 1 is 1. So that's going to, or wait, 1 times 1 is 1. So 5 plus 1 is 6. 6 times 1 is 6. Negative 21 plus 6 is going to be negative 27 plus 6 is negative 21. Negative 21 times 1 is a negative 21. That becomes a positive 10. 10 times 1 is a negative or a positive 10. All right, now let's go and see if this is factorable, right? And automatically I can tell that that's not going to be factorable. So that's the remainder, constant, linear, quadratic, and that's the cubic. So technically, I have one factor, right? X minus 1. And then my other factor here is x cubed plus x squared plus x plus 10, right? So what I did by doing this is I've just factored this down. Now, obviously, if this was factorable, right, by grouping, you could go ahead and just factor it. But it's not factored by grouping. So therefore, what you need to do is you need to find another 0. And you need to find another 0 and then do synthetic division again. But make sure you only do synthetic division with this answer here of 1, 6, negative 21, and 10. So I don't know what the other 0 is. I'm not going to go ahead and play guess and check for the rest of these. If it was me, I would just use graphing technology and figure out what real x-intercepted is. But if that's not available to you, then yeah, you're just going to have to plug in all these numbers. I always start with positive 1, then go to negative 1. Positive 2, negative 2. But again, we could spend all day. I mean, it could be negative 10, right? Would be the last one to guess. So just make sure once you find a 0 to get 0, use synthetic division to get that answer. Hopefully, if you already have another 0 or you need to find another 0, then you do synthetic division again with that 0. And then that answer will be a quadratic. And therefore, it's either going to be factorable or you can use the quadratic formula to find the remaining zeros. But just remember, by the fundamental theorem, you're going to have a total of 4 zeros, real or positive, real, imaginary, or irrational. So just make sure you're getting those to satisfy that. All right. Wow, that was a lot. All right. I did want to get to one more question that I was going to try to add. I do apologize. I know some of you guys have kind of joined in on the stream, and that's usually the way it always works, guys. People add into the stream and then they have their questions. But unfortunately, I am just unable to get to more in, but I definitely will be around next week again doing another open stream. But again, I can really rely on the importance, for me doing these like in the 30 minutes. If you guys can really try to submit those questions on the community tab as I post them, or send me a message on Facebook, then I'll be more than happy to do it. But let me kind of get back to actually the original question that I had. So let's see, because I did say Sky, she was looking for 1, and I think I'll just be able to do. Wow, there's a lot of good questions for you guys. Thank you. All right, so we have basically a question of A is equal to, or the formula P times 1 plus R raised to the T. All right, and correct me if I'm wrong here, Sky, but basically what we have is, so she's paid $32,546. The time that it took her for the time that she paid on that loan was 5 years. She had an interest rate. Yeah, I'll just do that. Why is it so bad? So we had an interest rate of 4.2, and that was compounded. Was it quarterly? Oh, no, per annum. So that's an annual. So compounded annually. Jeez. All right. How much was her original loan? So what was the original loan? Okay. So the nice thing is I was thinking that was compounded. No, it is quarterly payments. Oh, after 5 years of making quarterly payments, compounded rate was Okay, so I'm thinking you are making quarterly payments. So compounded quarterly. So let's actually erase that there. Okay. All right, so we actually have to use a different formula. And the formula is going to be related off of here. And I am just going to have to give a little feedback. I'm not going in front. This is the formula you gave to me. So I'm assuming I'm going to remember this correctly. But when we have an interest rate, we're going to divide it by here the number of compounding periods. And we need to multiply that by n times t. So again, this is going completely off old memory. I do apologize if I'm making a mistake. I'll try to make sure and update in the boxes, but this is what happens for the live stream. So I'm pretty sure, at least based on the knowledge that I have here, is, this is what we're going to do. So this would be for an annual interest rate or an annual compounded periods. But now we're doing, since it compounded intervals, we're going to need to take into account that, compounded quarterly. So in this case, we're going to say A. So you paid. That's how much you paid. That's your final amount. So that's going to be your A. The time is T. The 4.2 is your rate. And your compounded quarterly is going to be your N. And what we're going to look for is our original value is P. So A is the final amount. P is the initial amount, which was like your original loan. And then we have your interest rate divided by N, and then quarterly, raised times N times T. In my scientific calculator or my graphing calculator, I have worked. So that's why I was like, let me just work this out. But it's like really close to dying. So if that dies, I'll at least give you what you need to solve for. So 1 plus, so that is going to be, not 4.2. That's a 0.042. Divide by 4. Raised to the 4 times t, which is 5. All right. So then basically your p is just equal to this. So your graphing calculator, this is what you're going to plug in. 46 divided by 1 plus 0.042 divided by 4 raised to the 20th power. All right, so I'll try to do this in my calculator as long as it's working. It says charge recommended, so let's see, 0.042 divided by 4 plus 1 raised to the 20th, 32,546 divided by second answer. And it looks to me, that answer looks right. It looks like your initial amount of your loan is $26,410.17. However, I'm not 100% positive just because it's not something that I'm currently teaching. And as far as the formulas, I just wanted, and I'm not sure exactly on your question either, but I believe that should be hopefully rather accurate for you. All right, wow. So anyways, guys, I just want to let you know there's all these questions have been pre-submitted for the live stream. I really do appreciate you guys coming in and, obviously asking some questions and help. I do apologize. I'm going to go through the stream now and just kind of see, if I can maybe answer some questions just kind of, by chat. But I'm just going to have to end the stream here now just because I got other things I got to, cover for getting prepared for class tomorrow. But I will let you guys know I am going to do another off stream. I'm not sure when I'm going to do it. Maybe on Wednesday, I'm going to go through our second quiz. And I'll open up some questions for that. It'll just kind of be, I'm not going to do questions ahead of time, but it'll be around this 9 o'clock, time frame. And so therefore, if you want to kind of hop in on that stream and have some questions, I'll after I go through my quiz, I'll jump onto some questions. But otherwise, I will do another open Q&A, guys, next week. I appreciate you guys tuning in, and hopefully this was beneficial if you submitted a question, or it was beneficial if you were just hanging out in the chat. So I also always do appreciate you guys that for those of you that can answer other students' questions inside the chat, because I'm not going to be able to get to everybody's. So, that is one thing that's been happening, quite a bit. And I really, really do appreciate those of you that are able to help students that are, are in a lower math class, or at least something you understand, because, I think we've all been at that place where we get stuck on a problem or don't know how to do something. And regardless, if you're in this, live stream, we have people of all levels, in here. So I really do appreciate you guys helping each other out and answer that. And I look forward to the next live stream. But otherwise, I'll have to finish off here now. See you guys next time.